like Dr. Dean talked about, we're going to do some feature engineering. So just a couple things as we're prepping for modeling the data. The library that we're going to use is called scikit-learn for modeling this. So we have to be able to separate what we're predicting, that survived column, and the rest of the predictor columns into separate objects. So we'll do that a little bit later down. The features and the response all need to be numeric. So some of these categories that we're going to need to convert to like a dummy variable or some way for it to be more numeric. And then the features and the response should be NumPy arrays. Question?
Could you just turn some of the lights off so we can compare the
Sure.
screen?
Yeah.
Which one? That one.
There you go. That second option is pretty good. Not that one, the
I
other
think
one.
we're at the same.
That good?
Yeah. All right.
And you might increase the size of the notebook a little bit by, what is that, guys? It's like control plus. Just bumps the font up a little bit. There you go. Okay.
So this first box is going to strip out those titles like the Mr. or Mrs. and be able to do that. So just to show how this .loc function works, I'm just going to pull out this first piece right here. We're just going to see in the data set, the name column, if it contains Mrs. And so what that's going to show is just an array of trues and falses. And the .loc is going to basically filter on all the trues. So in this case, we're just going to do .loc where the name contains Mrs. and we're going to say we're going to add a new column called title, and that value is going to be Mrs. in that filtered set, if that makes sense. And then we just filter the same set, or filter it again to do all the Misters, where the Misters is true, and then we'll fill those in with Mr. and Mrs. and so forth. So that's kind of how the .loc works. Let's see. So then let's.
Why just the PD is null for like as a second argument?
So that it's kind of weird with the Mr. and Mrs. Sometimes they would overlap. If it contained Mr., it also would contain Mrs. So I was just saying we've already filled in the Mrs. So let's also exclude those ones. So let's fill in just the ones that are null that are left. Because this first one is going to just basically set the Mrs. variables to Mrs. And then in the second time, Mr. is also going to include the Mrs. Just because the string contains thing was weird.
So you really didn't need to put the first part of that and, right? You didn't really need to put train.lock. You could just put pd.is null and run through it and fill it in.
No.
Because we also have miss and others that we ought to do. But that's kind of why, because Mr. also grabbed the misses, but we already filled those in, so I was excluding those.
I just didn't know why we grabbed this MR period.
I don't know.
MRS.
Yeah, I don't know exactly how the string contains function works, if it includes some of it or all of it. So.
Yeah. So I assume we are trying to find gender from that using this computation. So if there is already a column for sex, why is it like we are having trying to?
Because a Mr. is an adult male and a Mrs. is an adult female, so it's more than sex, it's also age.
Mm-hmm.
So we're pulling that dimension out as well. Yeah.
Some.
Well,
We have the age, but
yeah.
I mean,
Married, right? Is that what it is?
Miss and Mrs. I
Yeah,
mean, it could be
does,
married
right.
as well.
Yeah, it does.
So yeah, I mean, you could use it using age and sex to kind of get a general idea, but this is another way that you could potentially do some feature engineering.
We actually tried it without and with doing this, and this does help the model predict more. So the fact that they're an adult Mr. and an adult Mrs. versus a Miss, there's some information there. It isn't just in gender and age.
Okay. So the D types, I think Michael and Jeremy went over this, but this just shows you what type of each column is, what data type they are. So here we'll create the family size variable, which is just the number of parents and children column plus the sibling and spouse column who are on the ship with you. So that's just another way to do some feature engineering that might be helpful. Um, so now that we've got created some new features, let's get rid of the columns that aren't super helpful for us right now, like passenger ID or ticket, which are unique um, to each passenger, and then like the sibling, spouse, and parent-child. Since we kind of combined that into one variable, the family size, we're just going to drop some of these.
Question.
Yeah.
Does the drop method return the new table? Or does it return like columns? It looks like it returns the new table, but
I don't remember off the top of my head.
So it's dropping these and then it's returning a reduced, a truncated train with less columns. Is that a thing?
Well, I already did it, so.
Yeah, you already did it. So, but yeah,
Yeah.
that's what it's doing. So it's essentially when he did train dot drop, it extracted it, it punted those columns, then just retained what was left.
Are you just asking if you don't need the train equals train dot drop? Or?
no, I was just curious of the opposite. Like,
Oh.
is there something, not train dot drop, but train dot something that
Oh.
returns the dropped columns?
Oh, I haven't looked at that.
Probably is a way.
Probably.
Yeah. So. Okay.
Random curiosity.
Now, well, it isn't quite so random. I mean, the other thing you could do it yourself. For example, you could do it with train dot drop, and then, but on the left instead of train, you could call it train drop, or you know what I mean.
If it was the
So yeah, so
columns
you
that
could,
dropped.
and so by doing different names on the left, you could have the retained ones, and then you could have
Yeah.
the ones that were dropped, and you could make things work like that.
That'd be helpful. So if you want to put them back in, then you have it somewhere. So.
Yeah.
Good point. Okay. So sometimes numbers aren't necessarily numbers. So like for the example of the passenger class, the P class, like it's 1, 2, or 3, whether it's first class, second class, or third class, but it's not necessarily a number that you'd want to do math on. You can't like find the average class, if that makes sense. Wouldn't want to do math on that thing. So we're gonna to change the type to a category, even though it's kind of a number. And we're just going to go ahead and do it with some of these other categories that we have. They're usually just like strings or objects, but we're just going to convert them so that people in the future can know that, sometimes this is a category that we're using. So the main one we're changing the type for is this P class, but we're changing the other ones as well. So now we can show that, yeah, we have our, did I run that? Oh, I didn't. Let's see. Where did we get to? Let me just restart from the top real quick. Down from this feature engineering stuff. We got our family size. We'll drop these columns. And we've got our columns here. Okay. So now we can see we've got some of our category columns. So the scikit learn library, for the modeling, you have to change any of these categories or these string or objects data types to numbers, to numeric, and so we're going to create some dummy variables with these categories. And so there's a function in the pandas library called get dummies, where you can input your data set and then the columns that you want to be turned into dummy variables, where basically, like for sex, it would turn into is male or is female, and you'd have ones and zeros for those. And so you can add prefixes to each of the different columns, and I'll show you when we see the data afterward. But an important thing to remember is we want to avoid the dummy variable trap, where if you have both is male and is female, if you have one, you really know the other, because if it's a 0 on the is male, then you know that it's a female. So there's an extra argument in this function called drop first that you'll need to add so that you can make sure you drop one of the columns so you're not having two things that say the same thing.
If you don't do that, your algorithm will not run. It's that important because essentially you're giving the same variable twice. So like you said, so let's assume with gender or sex, okay? If it's a 0 or 1, 1 for male, 0 for female, and then you have another female column, it's 1 for female and 0 for one. If you know one of those, you know the other. Does that make sense? So if you put both of those in at the same time, your algorithms usually fail because they're like, wait, you're telling me to use the same information twice. That's screwy, you know. So this drop first says, okay, once we've got the dummy variables, we'll drop one of them so that we're not overloading you with redundant information.
This is kind of what the result looks like. Just say, for example, this P class column that we created. It's going to take this prefix P class. So we had the options of 1, 2, or 3 in that variable. So it's going to say P class prefix underscore 2 and 3 because it dropped number 1 because we only need, you know, the total number minus 1 of those columns. So that's what it looks like after we do the dummy variables. You can look at this documentation, but there's another way where you can actually just factorize these categorical variables. So like, for example, with the titles, how we have Mr., Mrs., Miss, and things like that, it'll just assign like the number 1 is Mr., number 2 is Mrs., number 3 is Miss, and so on and so forth. But that's just another way where you can change it to numeric, but since we did the dummy variable way, um, we'll just go ahead and stick with that. So you can look at the documentation of how to do that if you want to do it that way. I mean, just, yeah, question?
So what is the, I'd say, like advantage when we use this categorical approach versus replacing that with the numerical values? For example, like replacing male with 1 and female with 2 versus making it categorical like 0 and 1.
Yeah. So one thing that's kind of interesting thing is it almost seems, it could seem to the model there's like an ordinal um, order to it, if that makes sense. So it's, you could say, well, is Mr. greater than Mrs. if it's 1 versus 2? Does that kind of make sense? How sometimes we want to avoid, because there's not really an order to some of these categories, so that might confuse the model a little bit. That's just one thing I thought of. But
No, that's right. Now, some algorithms are written so they can just handle categories automatically. Okay, like K and N usually can just do it without dummy variables. Some, like MLR, multiple linear regression, have to do dummy. That's the only way to get a category into the model. With scikit-learn, it's set to only handle numbers. So it's okay. We can take categories and use dummy variables to express the different categories. And so, but we'll see when we'll do some in Python, and we'll do some in Jump, and I'll say, okay, in Jump you don't have to do dummy variables because it can just handle it, but in Python we will because that's how it deals with dummy variables. So it's okay. That's a good question.
okay. So, so we did the dummy variables. Another thing that can help us see which variables we want to include is a correlation matrix. And this is code that Dr. Dean figured out that will show how correlated some of these variables are with each other and whether they're negatively or positively correlated. And so we can see, like, if the title Mr. is strongly negatively correlated with survived, then we can know, okay, maybe this title is a good indicator, a good predictor of whether the person survived or not. So this can kind of help. And also, like, if some predictive variables are quite strongly correlated with each other, then you might want to like exclude one of them because they might like predict the same thing, if that makes sense. So that's what that is. So if we go back to looking at our describe function, our summary, like we mentioned earlier, there's some of the age values are missing for the passengers, and so we're just going to do a simple just fill in the missing ages with the median. There's other ways that I think you talked about earlier where you can kind of do a little mini regressions and figure out what would be a good replacement to fill those missing values in, but we're just going to do a simple replace with the median. And so if we're trying to get the median from the NumPy library, there's a function that you can get for a column. It returns NaN because it doesn't deal well with those missing values. And so we're just going to get the median for all the values that are not missing. So we're just going to exclude through this not null, just exclude those missing ones, and we'll get the median, which is the median age, which is 28. And then we'll just use this function fill NA, which will fill in any of those missing values. And so we'll just paste this function that gave us 28 and paste it in right here. It'll just fill in those missing values. And then if we go back to the describe, we've got our same count of ages with the other variables. So that's how we can deal with one way we can deal with missing values.